In this video, I want to show you what I call simple factorizing because it's the most straightforward kind of factorizing compared to the other methods for factorizing, which you'll find on my website. But I have to say, this example is not exactly that easy. If you want to find the most basic example of factorizing, which is actually the same method as what I call here simple factorizing, just search basic factorizing on my website. But if you've seen that already, check out this slightly hard example of what I call simple factorizing. So simple factorizing basically means finding common factors within an expression and taking it out to one side. It's the opposite of multiplying out brackets. So when I factorized it, it will look like this, and when I multiply this stuff back out, it will go back to my original expression that I factorized. Okay, so what I'm going to do, this stuff, by the way, is the same as this stuff, just copied out again. What I'm going to do is I'm going to find common factors within each of the products in the expression. So this is a product because everything here is timesing together. This is another product, and this is another product, and all separated by plus or minus. So it's easy to distinguish between the different little groups. Okay, and for each of the little groups, I want to find the highest common factor between the groups, I should say. So let's break it down. What's the highest common factor for each of these groups in terms of the numbers, the plain numbers, i.e. the 8, the 16 and the minus 20? I know there's a couple of common factors, like I can say 1 is a common factor between 8, 16 and minus 20, so is 2. But so is 4, and 4 is the highest common factor of 8, 16 and minus 20. So I'll put 4 there in my list of common factors. Okay, and I'm going to put a few more common factors in a second. So let's look at the x's. We've got x squared, we've got x squared there, we've got x squared there. So clearly the highest common factor for x squared is just for x's, I should say, is x squared. So there you go, put x squared next to my 4, which is my other highest common factor. Now let's look at the y's. We've got y squared, we've got y, and we've got y. So the highest common factor between the y's in each of these parts is y, basically. It's not y squared, because y squared is not something you see in each part. You see y is the biggest factor in each of these. Y goes into that, y goes into that, and y goes into this expression. So let's add y to our list of highest common factors for each bit of this expression. And that's it really, because if I look at, say, P is only found in this bit of the expression, it's not there or there, and the same with Z, it's not found there, there or there. Sorry, well, it's found there, but it's not found there or there. So that's my complete list of common factors for each bit of this expression, and now I have to think that times what will multiply back to that, because remember, factorizing is simply the opposite of multiplying brackets out. So if it's the opposite, that means if I multiply my brackets out, you'll get what you had originally. So 4x squared y times what makes 8x squared y squared. So it sounds a bit complicated, but when you break it down, it's not so hard. You think 4 times what makes the 8-bit? Well, 4 times 2, so I put a 2 there. And then I say x squared times what makes x squared. Well, you got nothing to do there, so you just leave it out. Y times what makes y squared, y times y. And then there's nothing else. There's nothing else there. So that's the end of the first bit of the bracket. Okay. Now I didn't say this, but in the bracket there should be 3 separate bits, because there's 3 separate bits in the original expression. That's how it works. If there are 2 bits in the original expression, there'll be only 2 things inside the bracket, 2 separate bits inside the bracket. Each bit separated by either a plus or a minus, stuff like that. So, carrying on, 4x squared y times what makes 16x squared yp. Again, it sounds complicated, but let's break it down. So 4 times what makes 16? Let's deal with just the number bit first, yeah? So 4 times what makes 16? 4 times 4. So that's the first thing in the second bit of our expression inside the bracket. So we got 4 so far. Then we go x squared times what makes x squared? Again, nothing. You just leave it blank. And then y times what makes y? Again, nothing. And then you got 4x squared y times what? What else do we have to multiply that's not in here? Well, we have to times this by p to get this p thing. So you just add on a p there. So p. So you got 4x squared y times 4p is equal to 16x squared y p. And then finally to the last bit here we go. So the question is 4x squared y times what makes minus 20x squared y z? Again, let's start with the numbers. 4 times what makes minus 20? It's minus 5. 4 times minus 5 makes minus 20. Notice I'm treating that take away as a minus. That's how you need to do it. Because minus and take away mean the same thing in maths and algebra. Okay, so carrying on. So for x squared times what makes x squared, because we're comparing the x squared bits, nothing, just leave it blank. Y times what makes y? Nothing, just leave it blank from there. And then what else do you have to times by? What's left over? Well, the z's left over, so you have to times this by z to get this thing here. So we've got an extra z to put there. And then we finally done the example. It sounds a little bit long, but with a bit of practice, it's not all that difficult. All it is finding common factors.